Hi everyone, welcome back to your favorite channel, your beloved channel Chemistry with RK. Today I have come up with a concept from organic chemistry, especially when it comes to the IIT or JEE or NEET point of view. This particular concept is very important in terms of organic chemistry, which is the first part of the hydrocarbons, that is alkanes. So today in our video we are going to talk about the alkanes introduction. We need to learn about few points regarding alkanes. Even if a normal student have to understand the concept behind this alkanes. So for that reason I have taken as many as possible examples and then in an easier way, okay, to make you understand in a better way. So before we start our video, I request you to subscribe to my channel, and then if you're already subscribed, so please do watch my video completely till end and try to separate the information I'm going to give you in this video so that it will help you in the end of your IIT or maybe NEET preparation. And then please, I request you to spread my channel. Please share it to your friends, share it to your relatives, those who are preparing for IIT and NEET exams. So thank you, and then let's start our video. So in this video we are going to take introduction about the alkanes particularly, and then we are going to see one or two preparation methods. Okay, and then let's start our video. So before going to our video, so just I have thought to give you the brief introduction of these alkanes. So generally, what are alkanes? Alkanes are generally, they are the aliphatic saturated hydrocarbons containing all single bonds in between carbon atoms. So you need to have carbon atoms के बीच में 100% single bonds ही होना है. So we should not have double or triple bonds in between the carbons. Very particularly, they need to have single bonds only. Only then we can call them as alkanes. This is generally a normal definition we define the alkanes is. Okay, and then what are they? Alkanes are the aliphatic saturated. What do you mean by saturated? Yes, we know that. Saturated is nothing but carbon के बीच में double triple नहीं होना है. Only we need to have single bonds, so that we can call them as alkanes. Okay, they are aliphatic saturated hydrocarbons. Yeah, first of all, what do you mean by hydrocarbons? Hydrocarbons are the compounds containing only hydrogen and carbon. Yes, methane, ethane, propane. And then when it comes to alkenes, alkenes are also hydrocarbons. Alkynes are also hydrocarbons. Particularly, we call this alkanes are saturated hydrocarbons. They are the saturated hydrocarbons containing all carbon-carbon single bonds. Clear? Right. And then next, generally they are called as paraffins. Okay. Alkanes are also called as paraffins due to their low reactivity. So, due to their low reactivity, we call these alkanes as paraffins. Okay, right. When it comes to alkanes have general formula, this is very important. This is generally, we are going to consider very important, that is CnH2n plus 2. Yes, any molecular formula which is satisfying the CnH2n plus 2, so it is said to be, or it is considered as alkane. It must belong to an alkane family. Okay, and then next let us move to generally while writing IUPAC name for alkanes, what is the suffix we use? We use suffix ane. That's why we attach the last three letters, that is ane. So generally while writing IUPAC name for any alkane, we take the help of ane as the suffix. That is the primary suffix. Particularly primary suffix, we take it as ane. So just I have taken few examples here. That is the first member of alkane. The first member of alkane we are going to have, that is CnH2n place में, CnH2n plus 2 के place में, n के place में 1 ले लो. So if you take 1 in place of n, then we are going to get, that is methane. So we are going to get methane, that is CH4. And now this root word, what is the root word we use? Yes, since we have only one carbon, we use meth as a root word. And then what is the suffix ane? So the total name will come out as methane. Yes, these are all simple things. Chalo, in the coming few slides, we are going to go into deep of the concept. So please don't skip it. Don't skip it. Just try to write down the data separately. And then next, if you take in place of n, if you take 2, Then we use the root word, that is eth, and then next the suffix we are going to use ane. So altogether we are going to get ethane. And then C3 prop, and then ane propane, and then C4, that is, if you have 4 carbons, that is in place of N, if you take 4, the root word we need to use is but, and then we are going to get ane. So butane is the formula. And then next, in alkanes we are going to see this particular condition. Generally, from the point which I have told you in the beginning, the first point, that is generally carbon के surrounding में double bonds नहीं होगा और triple bonds भी नहीं होगा, which means that carbon is going to satisfy all its valency 4 through 4 single bonds, right? So when we have 4 single bonds, obviously we are going to take them as 4 sigma bonds, right? So 4 sigma bonds. And now, while giving the steric number or number of hybrid orbitals, a total number of electron pairs, so we take the help of only sigma bonds, not the pi bonds, right? Pi bonds generally will not undergo in hybridization. Okay, so only sigma bonds we need to consider. So around this carbon we can see 4 sigma bonds, which means that we are going to have 4 bond pairs. So we are going to have 4 bond pairs, and then we don't have any lone pairs in fact, okay. And now altogether we are going to get 4 electron pairs. Since 4 electron pairs are there, the carbon atom is going to undergo sp3 hybridization. Now coming to this point, each carbon atom in alkanes undergoes sp3 hybridization, and therefore 4 bond pairs will occupy 4 corners of a regular tetrahedron to give a tetrahedral geometry. Yes, in alkanes, sp3 hybridized carbon is going to show tetrahedral geometry. With generally when we have tetrahedral geometry, we are going to have 109 degrees 28 minutes is the bond angle. And now this is going to have tetrahedral geometry, very important, yes. I hope you understood why it is undergoing sp3 hybridization, okay. And now just observe here, I have given everything clearly, that is, yes, you please understand, try to understand. So carbon के surrounding में 4 sigma bonds होगा, 4 sigma bonds, 4 bond pairs, that is 0 lone pairs. We don't have any free electrons with the carbon to go as lone pairs, right? So 0 lone pairs altogether. Sum of bond pairs plus lone pairs gives the total number of electron pairs. If we have 4 electron pairs, we are going to have sp3 hybridization. And now, when it is having sp3 hybridization, obviously tetrahedral geometry, we are going to have tetrahedral geometry. And then the bond angle is, expected bond angle is 109 degrees 28 minutes. And then now, in a single bond, generally we will see only 1 sigma bond. Yes, in general, one single bond will have only 1 sigma bond. We don't have any pi bonds in this particular single bond. So that's what I have given here. In a single bond, only 1 sigma bond will be there, no pi bonds are present, okay. Yes, and then next, so if you see, when it comes to CC single bond and CC double bond and CC triple bond, that is generally I have taken example here of alkane, alkene and alkyne, okay. And now what could be their bond lengths and bond energies? It's very important. I am sure that these particular concepts must have discussed in even chemical bonding also, wherein bond parameters. So even in bond parameters we are going to get this actually CC and then bonds and then bond lengths, bond orders and all, right? Yes. And now I have taken again into here, see, just observe, try to understand. So when it comes to CC single bond, so its bond length is going to be 1.54, very important. Very important. In fact, it's better to try to understand and then try to remember the values also, because generally nowadays, since these all points are directly taken from the NCERT, so they are even asking sometimes the bond lengths also. There are less possibilities anyway to get this question in competitive exams. Direct number, that is bond lengths for CC, C double bond C. But what I am suggesting you is, better you try to understand the differences here among CC single bond, double bond and then triple bond and all, okay. Yeah, when it comes to CC single bond, so let me just take here, better you try to remember this in this way. Sir, I am giving you CC single bond in a longer CC single bond, okay. And now you try to remember, when it comes to CC single bond and CC double bond, what is happening to its length? length क्या हो गया? So generally the bond was a bit longer in the case of single bond, but the same single bond becomes shorter when it comes to double bond, and then when it comes to triple, it will become much more shorter. And now what we can understand here, since the bond length is longer, that will obviously have more bond length. So that is going to be 1.54 angstroms, and then when it comes to CC double bond, it is going to be 1.34 angstroms, and when it comes to triple bond, it is going to be 1.20 angstroms. Yes, you try to remember in this way. And now since the bond length is decreasing from N, En, Ein, obviously bond energy will increase. Lesser the bond length, more the bond energy. More the bond length, lesser the bond energy. Since the attraction, since the nuclear attractions will be, less here, because the bond length is more, obviously in दोनों nucleus के बीच में ज़्यादा attractions नहीं होगा, so we can just break that bond by giving little amount of energy. So that's what I have given here. Bond length is inversely proportional to bond energy. And now when it comes to, you just try to observe the bond energies as well. Bond energies भी एक बार देखने के लिए कोशिश करेंगे. And now since it is CC single bond, so this is 1.54, 1.34 and then 1.20, and then when it comes to CH, it is going to be 1.12. Okay, so this is the standard values. All these are the standard values. And now from here to here, bond length is decreasing, but bond energy, if you see, increases. 341, 681 and then 827. Hope you understood. Yes, you try to remember these points. Yeah, that will help you for your next coming concepts को easily understand करने के लिए वो हमको use होगा. But and now next, generally when it comes to the isomerism, okay, when it comes to the isomerism, so what we are going to see, alkane generally have a tendency to show this chain isomerism and then positional isomerism, optical and then conformational. About these four we are going to discuss clearly in the next slides. Hope you understood. Generally alkanes are going to show these four variety of isomerisms. Okay, and then next let us move to the first one, that is chain isomerism के बारे में देखने के लिए कोशिश करें तो just you try to understand just what do you mean by chain isomerism. What do you mean by chain isomerism? That is, yes, the molecular formula of the compound must be same, but the number of carbons in the parent chain must be different. Parent chain में carbon का number difference आना है, right? And now what does it mean? Suppose if we take this C4H10 as an example, so we have 4 carbons, right? So yes, we can arrange all the 4 in the one particular parent chain, that is butane. Simply we can take butane. And now since we have 4 carbons in a parent chain and the next corresponding chain isomer, you should not get 4 carbons. Anyway we have 4, and then in such case we need to take 3 carbons into the parent chain with one of the carbon as a substituent, that is methyl substituent we get. Okay, right? Hope you understood. Hope you understood, right? Yes. And now we are going to have one substituent, so that is what called as isobutane. We call this as isobutane. Now the question is, the minimum number of carbons to show chain isomerism by an alkane is obviously 4. With 3 carbons we don't get a chain isomer. We don't get a chain isomer because in order to call something as a chain isomer, we need to see the difference in the carbon number in the parent chain. So when we have 3 carbons, we can't put one of the carbon as a substituent. So we are not going to get. So we are not going to get corresponding chain isomer with the 3 carbons. So we need to go with 4 carbons only. So we need to go with the 4 carbons only. Hope you understood. And now, so that is the minimum number of carbons required by an alkane to exhibit chain isomerism are 4. Obviously we need to take 4 carbons containing alkane only to show the corresponding chain isomer. And now suppose let me just ask you, okay, with 4 carbons we have got how many chain isomers? 2. But now if I ask you with 5 carbons, suppose let's say if I ask you with 5 carbons, so C5H12 will be the molecular formula then. And now how many chain isomers possible for this? Generally what we do, yes, we do take 5 of them in parent chain. 5 of them in parent chain, so with no what do you say that? branches, that is substituents. All the 5 will be taken in the straight chain itself. So I am just representing it as 5 comma 0, where the first 5 defines the parent chain number of carbons, where the 0 is nothing but there are no substituents. And now what is the next alternate possibility? That is 4 carbons in the parent chain with 1 substituent, that is methyl substituent. And now what we can have? Yes, 4 carbons in the parent chain with 1 substituent. Yes, this is what is also possible. And now just you observe for the next corresponding positional isomer also, if we keep this particular carbon, that is methyl group here, then also we are going to get the same compound, that is 2-methyl butane. Come on, right? Yes. So we are not going to get any more in this particular 4 comma 1, that is 4 carbons in the parent chain with 1 methyl substituent, we get only 1 particular isomer. And then next if you move with 3, and now 3 comma 2, what do you mean by this 2? Actually 3 comma 2 ka meaning A hai, that is 3 carbons in the parent chain with 1 substituent containing 2 carbons. What do you mean by that? What do you mean by that? 1 substituent containing 2 carbons, that must be ethyl. And now where you are going to put that ethyl here? Suppose if you put here, then the parent chain is going to change. Alright, so we are not going to get this particular possibility. So 3 comma 2 possible nahi hai, तो हम 3 comma 1 ले सकता है. And now what do you mean by that? 3 comma 1 का meaning क्या है? 3 carbons in the parent chain with 2 methyl substituents. Yes, this is what I mean to say. So we are going to get 3 chain isomers for C5H12. Hope you understood. This is the simplest way to draw the chain isomers, just by taking all the carbons in the parent chain with no substituents, and then just take one of the carbon from the parent chain and put it as a substituent, and then further you go on doing this. For this we are not going to get this ethyl substituent possibility is not there for this example. But if you go to next C6, it may be possible. Okay, so please do consider all of them and try to write down them. When it comes to the positional isomerism, so how many minimum carbons are required to have positional isomerism? So that is 6 carbons. Yes, we need to have 6 carbons in order to have positional isomers by alkanes. So the minimum number of carbons required by an alkane to exhibit positional isomerism are 6. With 4, with 5, with 3, we are not going to get positional isomerism. What do you mean by positional actually? So the molecular formula need to be same, but the position of the substituent, or maybe double bond, or maybe triple bond, or maybe functional group need to be different. Here we don't have any double, we don't have any triple, we don't have any functional group, but here we can have a possibility of getting substituents, right? And now such particular possibility is not there in the case of 5 carbons. This is actually what pentane, right? And now what is this corresponding positional isomer? Positional isomer to isme possible nahi hai, but just if you see with 5 carbons we can have, just now I have taken this example previously. And now you can't put this methyl group any other position to get its positional isomer, because this is also 2-methyl butane. Even if we put this particular methyl here also, we are going to get 2-methyl only. So for that reason we are not going to get a positional isomer with 5 carbons in alkanes. But when it comes to 6 carbons, yes, you can have with 6 carbons we can go with the hexane. Yes, with hexane we are going to have, that is N-hexane is the first one, and now one of the group you just take it as and then substituent. So 5 carbons in the parent chain with 1. This is actually 2-methyl pentane. The same methyl group I can take it here also. Yes, these two are positional isomers. Such possibility is not there in the 4 or 5 carbons. Okay, right. With 6 carbons we are going to have the starting positional isomers. The minimum number of carbons are 6. Hope you understood. Yeah, here we have actually 5 particular possibilities of C6H14, that is for hexane. But if you see particularly the B and C, yeah, these two are actually positional isomers. And then when it comes to D and E, these two are also positional isomers. Hope you understood why they are positional isomers, right? So yes, this is the substituent position is 2, the substituent position is 3, and the substituent positions are 2, 3, and the substituent positions are 2, 2. So that is, we can able to call them as positional isomers. Next, when it comes to optical isomerism, the minimum number of carbons required by an alkane to show optical isomers are going to be 7. In fact, actually 7. But if we consider the isotopes also, then it is going to be less also. Okay, right. So generally, in terms of alkane, normal, if you don't consider, what I mean to say is, if you don't consider their isotopes, then the minimum number of carbons are going to be 7. How, sir? Yes, if you take this. So we need to have a chiral center, right? So here we are going to get a chiral center only if we take 7 carbons. So in the absence of isotopes, we are going to be 7 carbons are minimum required to have optical isomer. So we need to have a chiral center. So 4 groups must be different. Yes, these are the 4 groups. One is methyl, ethyl, propyl and then hydrogen. Yes. But if we consider the isotopes of hydrogen, it is going to be, what do you say that? The minimum carbons are going to be only if we have deuterium. Generally we have tritium also, but tritium is radioactive, so we don't consider it generally, right? So it is highly reactive. So they have different properties. So let us not involve this tritium into our lecture, okay? But generally, in the presence of isotopes, if we have, the minimum carbons are going to be decreased. So in the absence of isotopes, it is going to be 7. In the presence of isotopes, it is going to be 4. So hope you understood. Ethyl, 1 methyl and another one is deuterium and its corresponding hydrogen. Hope you understood. Very easy, right? Yes. The questions are possible. Questions could be asked from anywhere. That is, if they don't mention, generally the minimum number of carbons to have an optical isomer by an alkane is 7. Without any doubt we can go. But particularly there are few questions asked in previous exams, that is, the minimum number of carbons required by an alkane to show optical isomer with corresponding to its isotope, then it is going to be 4. Clear? Right. So उस पॉइंट के ऊपर थोड़ा फोकस करना है. And now next, if we move to the conformational, as we have seen, alkanes even show conformational isomerism. So we are going to have conformational isomerism also. The minimum number of carbons to have conformational isomers are going to be 2. That is, ethane को भी हमको conformational isomerism already GOC first में, GOC 1 में already teachers will discuss. But anyway, I am going to involve this conformations of ethane even in our particular lecture also. So please try to take the advantage of that, okay? And now the minimum number of carbons are going to be 2. Yes, without any doubt we can have ethane is going to show conformational isomerism. What do you mean by conformational isomerism here? Okay, so generally the conformational isomerism is nothing but the isomerism which is arised due to the spatial arrangement of atoms, okay, in the 3-dimensional space around the carbon. Yes, clear? Yes. And now let's continue. And now here we are going to get infinity number of conformations. What do you mean by that? Suppose let's say if you see the ethane molecule particularly, we are going to have this type of possibility where one of the carbon, if you try to just look at that particular compound from side view, we are going to have another carbon here. Yes, just try to understand. And now इस कार्बन को भी हमको हमारे पास 3 हाइड्रोजन्स है. Yes, we are going to have 3 hydrogens here. Yes, we are going to have 3 hydrogens for the front carbon. Yes, इसको भी 3 हाइड्रोजन है, right? Yes, and even the same possibility is also there for the backside carbon also. There are 2 carbons. Yes, these are the 2 possibilities. And now if you look from this particular side view, then you can't see the exact backside carbon, if I am not wrong, right? Yes, if you see exactly from the front view, इस carbon को एकदम backside में और एक carbon है. You just try to imagine in a 3-dimensional view. Okay, right. So we can't see the backside. And now suppose अगर इस particular 3 hydrogen को, if you just try to take or rotate or make some rotations, then what you are going to get? You are going to get at every rotation, you are going to get different orientations, conformations we call them as. Okay, right. So we ultimately are going to get infinity number of conformations for ethane. Not only for ethane, for any such compound, conformational isomers theoretically we are going to have infinity number of conformations, right? Yes. And now those conformations, if we try to project into different projections, we are going to have Newman projections and Sahar's projections. Actually this particular form is generally represented as Newman projection, where in each of these projections we are going to have a different number of conformations. Among them we are going to have eclipsed and staggered conformation are very important. What do you mean by eclipsed now? Sir, if the hydrogens are exactly at an angle, suppose let's say front hydrogen ऐसा है, back side hydrogen एकदम इसके parallel है, then generally, so if one of the hydrogen is like that, then the remaining hydrogens are also parallel to each other, exactly, right? So if you take the example of this, suppose let's say this is our front carbon. अभी front carbon को we have obviously 3 hydrogens are there. Without any doubt we can say, so we have 3 hydrogens for the front carbon. And now suppose let's say this is our backside carbon. अभी backside carbon को भी 3 hydrogens है. Yes, we have 3 hydrogens exactly. So I can't draw exactly back to that. So I'm just writing a bit next to that. Okay, right. And now similarly here also we are going to have. So this particular conformation is called as eclipsed conformation. And now just if you make 60-degree angle rotation to this, we are going to get its corresponding. So we are going to get its corresponding, the front carbon ka hydrogen हम ऐसे ही रखेंगे. And now if you see, if you try to make a 60-degree angle rotation, then the particular these yellow hydrogens, the hydrogens which are present on the back carbon are going to give us this. Yes, this is actually called as staggered. ये हमको इसको हम staggered conformation बोलते हैं. And then this is actually called as eclipsed conformation, right? Super. Any doubts so far? No, I hope you're perfect. Okay, so this is what we are going to have. So even alkanes do exhibit conformational isomerism. The minimum number of carbons are 2. Okay, so if you see, yeah, this is what I was explaining just now. So if you please understand carefully, this is eclipsed. Eclipsed means एक atom के एकदम parallelly, that is, it seems like both the hydrogens are on each other. So that is eclipsed. Eclipsed बोले तो exactly ऐसा एक के ऊपर एक superimpose होगा जैसा. Okay, and they are not going to superimpose anyway. Yes, so this is eclipsed conformation. And now staggered is, yes, in between these two, suppose if you ask me to write down some angle, yes, they are going to rotate through 60-degree angle rotation. Yes, any doubts in that? No. So for every 60-degree angle rotation, eclipsed is getting converted to staggered, staggered is getting converted to eclipsed. And in between these eclipsed and staggered, we are going to get different number of conformations. Directly we can't make an angle of 60. So in order to move from eclipsed to staggered, we have to cross all the different angles. So those particular conformations are called as skew conformations, which we actually, I'll try to make out a separate video on this conformational isomerism then, because actually when it comes to IIT and NEET point of view, that is JEE mains, advanced and NEET point of view, the conformational isomerism is going to be very crucial, very important. Okay, right, I'll come with models actually. Okay, so I was thinking just to give you some small idea about the conformational isomerism. I hope you satisfied with this. Okay, but when it comes to conformational isomerism separate video, I'm going to give you with proper models and all, so that I can satisfy you 100%. Okay, so that you can solve more number of questions with very much ease. Okay, right, let's continue. And now this is actually called as Newman projection. And then when it comes to Sahar's projection, yes, this is what Sahar's projection, same to same, that is, if we just try to rotate any of this particular, suppose see, I'm just making this 60-degree rotation again. So this will come here and then this will go here, right? Yes, so we are going to get this. So this is again a eclipsed conformation and this is the staggered conformation. Hope you understood. Right, so this is all about the introduction part of the alkanes. So in our next video, I'll soon come up with a preparation method. I'm going to go to the advanced not only me, I'm going to take you with me as well to that advanced level. So please wait for next video. Thank you so much for watching this video. See you soon.